Hey, hi guys. I hope everyone is doing well. So I'm resuming the videos after a break of almost 2 weeks. Primarily reason being I was not keeping well and was little under the weather. Uh, I have been like preparing the videos for quite some time, and I think this is probably the longest break that has happened, I think, in posting the videos. So I really apologize, I think, for the delays. I hope, I think, you have been able to watch whatever videos have been uploaded, the last one on the PM tools. And also, I think to resume back, I think I thought, like, I think the basic use case is right of system design, which is also very like relevant from an interview perspective, would be to deep dive into a case study. So I think today's discussion is primarily going to focus on feed systems. So feed systems, for example, LinkedIn is a great example where you do get regular feed updates. Then there is also Facebook posts, right? Reddit is also another one which would more or less function in a very similar way, right? And couple of other, I think, news feeds, like maybe Quora and others that can also use more or less a similar structure, right? So without dealing further, let's start with the high level design. I think we are so. Just to recap, I am still going to use the same framework that I've used in designing a Google Drive and designing a Messenger, which is I will talk about the high level design, I will talk about the low level design, I will talk and get into the user estimates, then into the data models, what are the APIs that are required, right? And then finally, the system components, bringing it all together, right? So let's start with the high level design for the feed system. So, what should the users be able to do, right, as part of this feed system that we are developing, right? So, I think feed is obviously generated using the posts, and that is typically from the other entities that are signed on to the platform, right? And in LinkedIn's case, I think you can subscribe now to certain users, you can subscribe to certain groups, right? So, which is what these entities mean here in the system that the user followed or the user might be interested in, right? Posts can also have text, images, and videos, right? Uh, and a new post basically that is generated by uh, a user other than the user himself or herself should be appended to the newsfeed of the user. So every time there is a new news post, that should be following the post that is already, like, seen by the user. And then I think users can receive notifications for new messages, let's say calls or any other important events, right? So high level functionality would be like, I think, these four or five different aspects of the uh, overall system, right? Now coming to the low level design, right? Since this is a feed system, where means like the updates are actually happening near real time, right? So the feed generation should happen in near real time, right? You can use distributed cache such as Redis, or let's say maybe you use an in-memory caching solution such as Amazon DynamoDB accelerator, right? The other thing is that this has to be a very highly scalable system, right? So you're going to use horizontal scaling, and the reason for that is that you want the databases to be created and maintained locally in different countries, correct? Master slave node replication, I mean, it's a standard practice, I think, when you're looking at scalable systems, right? And then high availability, right? So appending, I think, new content or posts. Basically, all the new posts should appear in less than, maybe, let's say, 1 second or 2 seconds, threshold time, because that's when the feed will get refreshed with the new post, and the users will be able to discern the new posts, right? So If it is like 5 seconds or maybe let's say 10 seconds, right, then you are looking at probably a lag of sorts, right? Which is not a great user experience, right? So that's why I think all of these three aspects of the low level design are super, super important, right? Now, I think for such a system, as you can imagine, like I think the number of users is going to be tremendously high, right? So let's jump into maybe the user estimates, right? Uh, I think what it will help is to understand. I mean, this is just a framework, right? When you're looking at user estimates, there's no exact, let's say, numbers that you are expected to come to. But your estimates and your assumptions, I think, should follow a series of steps, right? So I am starting with, let's say, the daily active users, which I'm assuming is 100 million. So it could be 1 billion as well. I mean, it could be 10 million as well. I have no idea about that, but what I'm going to do is I'm going to stay consistent with this daily active user count, right? So let's say I'm assuming that a user is following around 200 users, right? And I'm assuming that a user fetches feed, let's say almost 10 times a day, which is the refresh activity that you see, right, on the LinkedIn feed. Uh, so I'm assuming that not more than 10 times a day, a user will feed the fed, right? So I am looking at what are the number of requests that will be generated. So which will be this number of active users multiplied by the feed fetch that is happening. So it's 1 billion. So 1 billion requests per day. Now, in terms of queries that are being fired, right, to generate this amount of enormous feed data, right, you're looking at 1 billion and then 24 hours and 3600 seconds, right? So I'm looking at around maybe 11.5, 11.6 k queries per second. That's a pretty big number, right? So this is on the query side, which is basically bringing in the data. What about the storage, right? uh, so per user, obviously you'll have some number of posts that you want to keep in the feed memory, right? So remember, there will be always be a concept of the dynamic memory and the static memory. Static memory feeds will take like I think a lot of time to fetch the data, but this, because being instantaneous, right, we allow for, let's say, maybe 100 posts of each users, right? Maybe you can build some logic which could be like the most recent hundreds or split it by days, whatever it is, right? I mean, some logic to keep a finite amount of posts for each users, right? Now, I think each post also will have some size, so I'm going with 1 KB size, right? Now, the final calculation basically, which would be my 100 KB, which is 100 posts into 1 KB, into my 100 million daily active users. So, which is 10 to the power 5 into 10 to the power 8, 10 to the power 13. Remember that table that we had talked about? 1 KB is 10 to the power 3, 1 MB is 10 to the power 6, so on and so forth, right? So, 1 10 to the power 13 would be around 10 terabytes for daily active users, right? So, this should give you a fair bit of idea. Now, what I can do is like maybe give you an exercise. Instead of a daily active user, what would be the storage estimate if I told you that I have an overall 500 million users overall, not the active users, 500 million users overall, right? What would be the storage estimate? So you can leave the solution or like answers in the comments. Um, Use the framework, I think, for the storage estimates and come up with, I think, maybe some assumptions around posts, for example, right? And do, I think, leave it in the comments, and then I'll get back to you with the answers, right? Now, coming to the next part, which is related to the data models. Why are data models important? Because it helps, I think, the interviewer to understand. Uh, it'll give an idea that you do understand how the data is stored, what are the different maybe relationships, entities, right? Is it required? I think it is required if you're looking at the full spectrum of a system design interview, right? So I think for data models here, right? I mean, what are we looking at? We are looking at a user entity. We are looking at a uh, entity, let's say, such as a page, right? A page could be part of a group. Page could be part of, let's say, user itself. Uh, Homepage, right? And then you would also have post and media. Now, when it comes to data model, you need to define those using certain, let's say, attributes, right? So, entity, for example, is a page, a group, for example, right? Identifying each of those will require an ID, entity ID. You can also have the name, description, and maybe let's say when that particular entity was updated or created or deleted, whatever, right? So, together with these, I think 4 or 5 different attributes, you are able to define an entity. Similarly, for the post, how do you define a post? A post will definitely have its own ID, it will have its own title, description, who is the author of the post, and when the post was actually created, deleted, edited, etc. Right? So those are like the standard I think attributes. Now, coming to the media, right? I think again to identify a media, you can always put in a media ID. You can always have a URL. You will always have a timestamp, right? So this is just not limited to I think these 4 entities. You can extend it to any number of entities. But the important point about those entities is that you should be able to identify each of those entities uniquely, right? So post should be able to be identified. Threads, for example, right? If I am starting a thread, let's say in Reddit, I should be able to maybe identify it, right? Communities, for example, right? I should be able to identify. So these are just examples that I can think of, but not limited to only those, right? And then what happens to those entities? They're going to definitely follow some relationships, right? So what it means by relationship is that I am following you, you are following some other 100 people, and 100 authors, right? So that is basically a relationship, a follower-followee relationship, wherein a user can follow other users or entity. It will be an M to N, which means it's going to be many to many. That's how I call it. M to N means many to many relationship, right? Then you can also define the author post relationship, wherein the users and entities are generating the post, right? And assume that only the users can generate the post, right? So one is to many, which means that one user can generate many posts, right? And then post to media, right? So each post could have some associated media, one to many again, which means that one post can have multiple media components, right? So I think defining the relationships helps you during the interview to at least give a clarity of the entities that you have defined. How are these actually related to one another? Either they are related in many to many relationship, or they could be related in one to many, or the reverse could also be true, many to one also. Right? So I think data models give the idea that you are able to understand what the table structures are, how are the tables actually linked by the concept of, let's say, primary keys and foreign keys, right? Because eventually either you are going to store the data in a SQL database, right, or maybe using a key index pair like NoSQL database, right? So this is all about the data models, right? So now let's jump into APIs. I think so. For APIs, there's no fixed pattern as such, like to define, right? But I think it should maybe limit to probably some 5, 7, like useful functions that you want your system to perform, right? So get feed, for example, right? Get feed is, as the name suggests, right? I'm trying to get the feed, right? So remember when you had used the user estimates, also in the user estimates also I had talked about that one user is, let's say, fetching the feed. How is that user going to fetch the feed, right? This is this get feed function, right? So in this get feed function, I am, let's say, trying to get a feed for a particular user. So I have to definitely pass a user ID, because that's the one ID that is telling me for whom am I actually trying to get the feed. And the optional parameters, right? So this params field, basically, you can look at after post IDs, you can look at counts, you can include, exclude replies, right? So let's maybe get into the detail of what it means by these parameters. So after post ID, let's say, means the fetch the feed from after the post. So once, let's say, you have done the post, there will be, let's say, feed that is generated after the post. There will also be a feed that is generated before the post, right? Because the posts are not going to wait for your, or the feed is not going to wait for your post, right? I mean, it's constantly being generated. So after the post ID will tell, like, I think for this particular user, that you're looking at only the feed from after the post. And if you don't specify this, let's say maybe this is an optional parameter. If you don't specify it, maybe you just fetch the latest 10 top newest posts, right? Something along that line. In terms of another parameter called count, the maximum number of posts that you want to request, right? And if you don't specify that number, maybe some default maximum number, let's say, is like, kind of return. So maybe 10 or 20 or whatever it is, right? But you tell, right? I mean, the amount of feed posts that you want to return. Exclude. So in posts, you also have replies, for example, right? So if you want the feed not to show the replies, then I think you can pass this parameter. It's kind of a flag, basically, right? And then this is how, I mean, usually you have seen in the past, right? JSON file structure is basically how it is, used to design and call the APIs, right? So uh, I think APIs from a definition perspective gives you and gives the interviewer, like, I think, fair bit of understanding that you do understand how different systems are communicating with each other, right? So APIs are primarily used for that. Now coming to the system components, right? I mean, this is probably the most crucial part, and we'll spend some time on this. And I have changed the, let's say, the outlay of it, which is going from the boring boxes, that were there, to make it more lively, and created some, like, I think, let's say, interactive visuals, right? So I'm going to switch to, let's say, the system components now. So for system components, right, what are the most important parts, right? So you would have your, let's say, uh, let's say, uh, just give me a minute. I think I let me quickly. So I'm going to bring this guy up, right, and let me, I think, present the screen again. So I think if you look at the I think components here, right? For the system components, there is a lot of, I think, static content that is generated. There's a lot of, I think, familiar components that you would have seen, right? Like your, let's say, like your uh, feed and load balancers and notification queues, right? So let's jump into each of those one by one, right? So I think for the to start off with, I think how I think this looks, right? You have a bunch of users who are signed up on, let's say, LinkedIn, right? They're communicating through, let's say, a network service, right? Uh, when the actual interaction starts, right, you will have a lot of queries from these users, which will be controlled by a load balancer, right, that you see. So a lot of queries being generated and being controlled to the load balancer. The load balancer is then going to push the queries to the API gateway. So remember, I think for API gateways, I had done a separate video altogether, which covered a lot of functions that the API gateway does, including the authentication, right? So authentication, let's say SSO logins, part of I think cloud services do provide it integrated with the load balancer, right? So you are going to use I think API gateways, right, to get into uh, the backend systems, right? So now let's say I think I'm looking at the app web server. So typically, this is the app web server that is utilized for the entire processing of your data, right? So you have the app write server and then you have the app read server, right? So the app write server, as you can see, right, I mean, this is the one that is writing back to your let's say database services, right? And if you're looking at the, let's say, the read server, right, the read server is nothing but uh, reading from, let's say, the different services. What are those different services? So notification queue, for example, right, search results, let's say aggregator, that is getting the data back and pushing it from the cache, right? So that is where I think the notification read services are coming into picture. Now, also look at, I think, this part, which is the user database. So for the user database, right, you are constantly reading the comments and the news feeds and, let's say, the posts likes, right? So what you can do is, for example, for each of these, run a separate service, like a like service, like a comment service, like a request service, right, or a repost service. Now, what it means is that in your user database, each of these services interacting separately and pushing the data, right? And so for the let's say, if you're looking at the read service, sorry, through the read service, through the read server, you're looking at, let's say, a comment, right? So the way the flow will happen is that the common service, basically from here, is looking at the information from the user database. That common service is then going to push the data back into the, let's say, the user database. Then that read server is going to read, let's say, for I don't know, maybe let's say you picked up the 10 maybe users, right, that are looking at comments. So from the user database, you looked at the 10 users, let's say all the description of the comments, text, etc. All of that comes back, and then the read service basically pushes it back through a notification, let's say queue. This notification queue basically is like that pop-up service that you get, right? And then the notification queue is pushing it to through the read server, link back to the notification service and back to the user, right? So that's one, let's say, way of looking at how the processing is actually happening. Now, I think I'll quickly cover, I think, all the important parts of it. So, load balancer, obviously, as I mentioned, right, start of the, like, I think, system, you are looking at equally distributing the request to API gateways, right? I think on, obviously, API gateways, along with redirecting the services, redirecting to the microservices, also helps with authentication, right? Now, what are the write operations? We touched upon the read operation, so we'll quickly touch upon the write operation. So API gateways basically route the write operations. Let's say example would be uploading the comments, right? Validating the request, writing the data, and handling, let's say, video processing. We'll touch upon it in more details. I'll give you the exact flow. But for now, I think I'm just telling you, like, I think these individual different components. So, what about the feed generation, right? So, the feed generation is a service and that generates and updates the user feeds. You have the read operations. We covered the read operations in great detail, which is API gateways routing the read operations, right? Now, I think for databases, obviously you have your user database. You can also have a metadatabase, right? Here, which stores the, let's say, user profiles and the post metadata. Caching, obviously, we covered like user Redis or a memcache, right? Depending on your data types. And this is primarily to reduce the latency, right? Search service, I think the search result aggregator use a service like an Elasticsearch, right? Uh, Blob storage, I think, for everything related to media, right? So here you see in the cloud, the static content, let's say, that is being pushed, right? So video, photos, and all of that. That's like the blob storage, CDN, content delivery network, everything that is static, right? And the notifications, running through the notification queue, right? So let's bring it all together for a, let's say, one let's quickly cover one example. So let's say I am a user, I have put a post. What are the different system that are going to be touched through when. So I am a user, the first step would be the load balancer routes me to the API gateway. The API gateway checks for the authentication, pushes a write server request, right? Now there's a feed generation service also, right? That is going to put the a request of my post into a queuing service, right? Why is that queuing service required? See, I think queuing is, as we had talked in the past, right? Queuing allows for a systematic asynchronous communication between two systems. So here, the database, right, uh, is not aware of, let's say, how many users are actually doing the comments simultaneously, but you still have to nonetheless store the data, right? So what this feed processing queue does is that first come first serve, let's say, first user to put the comment gets, I think, the feed, right? Then that feed with the comment, right? I mean, feed is nothing but, like, a collection of, let's say, your post or a single post, and your media and all of that, right? So that is basically pushed into the user database. The other part of that is related to the static content, which you can process through the CDN services, right? The static content. It also includes your photo, video. Let's say if you added those, right? Then that is going to be processed through the video image processing services here. The workers are going to obviously process it and then push it to the queue. So this worker part here, right, is this is not connected, but ideally it will be pushing the data into this feed generation service here, and then that is going to push the data into the user database, right? Now let's say someone had also liked the post as soon as you, like, put the post, or let's say after 2 minutes, 3 minutes, whatever it is, right? So again, like, I think the same process will follow, but what will be different this time is will be in this feed processing queue, uh, the like, for example, for the post that is already existing, the like service is going to basically pull out that post, increase the number of, let's say, likes, return the number of likes, and push it back to the user database. The user database is then going to get synced with, let's say, the read service. The read service is nothing but you're looking at, let's say, the post, right? And then that read service is going to maybe push the notification out and then out to the user, right? So this is how I think the flow is going to work. Try out, I think, maybe different flows through this interactive diagram here, and do leave comments if you want me to cover, I think, any of the flows. So I hope this video was useful for you to understand how feed systems actually work. I am going to post this as a LinkedIn post as well on my LinkedIn feed, which is the product managed